Hello, everyone. Welcome to Cloud Computing for Biology and Healthcare. Our speaker today is Zhamak Dehghani. She's going to talk about the introduction to data mesh. Zhamak works with ThoughtWorks as a director of emerging technologies in North America with a focus on distributed systems and data architecture. She has a deep passion for decentralized technology solutions. Zhamak serves on multiple tech advisory boards, including ThoughtWorks. She has worked as a technologist for over 20 years and has contributed to multiple patents in distributed computing communication, as well as embedded device technologies. She founded the concept of data mesh in 2018, and since has been implementing the concept and evangelizing it with the wider industry. She's the author of Architecture of the Hard Parts and Data Mesh O'Reilly books. I have the data mesh book here. If you are want to check it out and look into it. First of all, thank you so much, Zhamak, for being here and joining us today. So with that being said, I would like to hand it over to you.
Thank you so much for the introduction. Thank you for hosting me. And when I saw the name of this course, I thought, what a magical intersection. Medicine, biology, cloud computing, and data. So I feel very privileged being here and talking about data mesh. Let me quickly share my screen. I have quite a few slides to walk you through to talk about data mesh. You let me know if you can see my screen okay?
Yes, we can see it.
Okay. All right. So this is an introduction to data mesh, why we need yet another approach to managing data, what it is, and a little bit of how. I think Amir did a great job introducing myself, so I skip over this one. These are the two books, and the book that focuses on data mesh is the one that just got released in March. But before jumping into what data mesh is, I want to give you a bit of a macro view of what has been happening in the tech industry over the last 20, 30 years. Pivotal changes and moments that I think are very relevant to keeping the retrospective, as Carl Sagan says, understand these pivotal moments in the past to see where we're heading and how those changes shapes our thinking about data. So one of the big trends that I think everybody's familiar with is this growth in digitalization. Organizations transforming themselves to become digital natives, to use as a technology, not only kind of serve their business, but also use technology to inform and change the way the outcome of the business. So I've got a few, relatively actually, these are not super recent, but from 2020 to 2019, stats here to show the market growth for the spending around digital transformations. And I think the COVID probably actually impacted quite a bit these numbers and has been a catalyst for the acceleration toward digital organizations from $500 million to 1.2 billion, kind of the market size in 2020, and 70% of companies, claiming to have some sort of a digital strategy to becoming more digital. And I'm pretty sure if this stat was taken in 2021, the rest of that 30% had changed their minds as well and had digital transformation somewhere on their strategy. So we have that acceleration toward adopting systems that not only support our business, but also change the way we do business. And that accelerated digitalization had a major impact in how we build software. Around 2010, 2011, 2012, even prior to that, we had this kind of a slow and then suddenly rapid movement from thinking about systems and applications from one big complex monolithic system to this idea of a smaller systems that do one thing and do one thing really well, which is really a Unix philosophy, has been around for much longer than that, but really start thinking about the architecture of systems and business that way. So if you had organizations went from having a big e-commerce system or big, let's say, provider clinical system, and they started thinking about, okay, if I have a lot of people that try to change the system, this becomes a blocker for change and moving fast and creating new features. So what they started doing is moving to this architecture called microservices and containerization or distributed architecture to say, I'm going to break apart this as an example here is a retail application to its constituents, to its components, to its services. And every service does one thing really well. One service focuses on logistics, one service focuses on customer profile and so on. And these services then integrate and deliver higher order value or a end-to-end journey for the users through APIs and API composition. So this move to distributed architectures happened in response to the complexity of applications arising from this massive, digitalization. And then organizationally, we had, again, another shift. Organizationally, for a very long time, and still a lot of organizations are structured this way, we have these functional silos, as in you've got your business people focusing on the business outcome and business processes. You've got silo of developers building applications that serve those business outcomes, and then they throw them over the wall where they generate to these ops people, operational people that operate those applications that developers build. And these silos are actually orthogonal to delivery of the value. So these, as in you have to, throw a lot of things over the wall, business people throwing requirements over the wall and dev people, throwing software over the wall to actually get one end-to-end value. So then the change again happened in the 2010s up to now. Organizations are moving toward this domain-oriented structure that they say, okay, let's get people again around the concept of domain, which is a boundary of part of the business that focuses on a particular outcome or particular function, and let's business and developers and ops together to serve that outcome so that we can move faster, so that we can scale out as the complexity due to acceleration of touch points and digital function of the business, we can manage that complexity, right? So this happened again over the last decades. And the other thing that has happened is that over time, our relationship with data has inverted. So, if you look at how we have built systems and applications, traditionally we write logic, we translate human reasoning into code, we codify that human reasoning and logic, and as a result of execution of that logic, you generate some state, regenerate some data, and then you store that data in the service of that function. I'll give you an example in a minute. And that relationship with ML and data-driven applications is inverting, as in you have a massive body of data that has been generated through the touch points of users with the systems or through those actual logical functional systems, and you are exploiting and exploring this massive body of data to see what patterns and what logic actually, what functions arise from those patterns in the data. So let's see that in an example. Again, I give a retail example here. Let's say a business function wants to retain high-risk customers, with some special offers. So in the past, a developer sits down and writes a logic that if the customer is a member of a royalty plan and they've been around for, have been shopping with us for the last 3 months, and they are a member of royalty plan, but they haven't been engaging for us for a while, and they haven't done any holiday shopping. We reason that this customer is high risk versus, maybe they have been engaging, they've been already shopping, and so on. So that we start kind of figuring out how to reason about this high risk customer, and then we codify that rule-based, logic, and then we get, some answers, and sometimes they're false negative, and sometimes positive and false negative, because, and in main cases, because we couldn't see the signals from the noise of the data, because our logic could just reason about a few parameters about the customer. So what has changed is that we apply ML. So now let's say that we capture a lot of data points about the customer. Every time they engage, we capture when they engage with us, where they made the purchase, have they had any recent complaints, have they had any, we start recent purchases, we start collecting all of that signals about the customer or data about the customer. And then we train a statistical model, let's say in this case, a classification model, a vanilla, classification model, and then training through, adjusting the parameters of the model based on the data, we arrive at a trained model. In this case, let's say it's a risk model, and then we say, we decide which cluster or which classification the customer falls into. So again, we're not logically putting human reason in the code. We are actually driving the behavior of a decision around whether to reach out to this customer with special offer or not from the data that we've captured. What is one unifying trend that hasn't changed and has remained the same? And that's what kind of data mesh tries to challenge. If I walk you through what does data management, like before even getting to training a machine learning model or generating report and insights, how do we manage data? How do we get access to that data? And this is the kind of state of the art right now. I mean, I guess prior to data mesh, that on one hand, you have these businesses that, whether it's a hospital system, business, or, it's a clinical business, or insurance, they have really organized themselves on one hand around this concept of domains. Again, this is an example of the retail here. And they taking care of the state of the business, like current snapshot of what's happening in that business in the individual databases of these small kind of microservice applications. But for us to get value from cross-cutting, across the organization from all of these different business units and gather some insights about the customer or around the performance of our logistics or, how the retail stores are performing, the decision that the architecture has worked this way. It's a pipeline architecture that will say, okay, we're going to go get data from all of these individual application databases, move them through some form of an extract, transform, load, or extract, load, and transform, like different models, move them through some process across the organization, and then put them into a centralized way in a lake or warehouse, and I talked to those, so that we can get value from it. And of course, we have to have compliance, security, integrity, all of that kind of smeared all over this data. So then we have usually a centralized governance function that tries to control this process of data movement and data modeling and data storage and data access so that they can enforce points of control in this process for security and compliance. So there are different variations of this model. It was the first generation of this model where the data warehouses that they've been around, since the 60s, and the implementation has evolved, like you see BigQuery, Snowflake, different systems and different clouds, but the genesis of it is the same and the function is the same, that you've got these applications, independent applications, and you move data around through some form of a pipeline model and transform it and modulate and put it into a warehouse. The warehouse gives you this like very rigid modeling, but yet very flexible query style, star, or they call it Snowflake schemas that allow you to relate data that is being collected from across the organization. Like this customer has made these orders and these orders have been fulfilled by this retailer and so on and so on. So you can connect them and then you can generate metrics, dashboards, AI, ML. And then what happened was in the 2010s, when with the introduction of ML, that process seemed to be unoptimized because it had a very heavy modeling phase. And that heavy modeling phase was, first of all, removing some of the signals from the data for the data science perspective. So because data scientists, they wanted to explore the data in its raw format as close to the source as possible, as opposed to some form of a modeled format that it lost perhaps some really key signals in that data. So what they said was, okay, what if we change this process that we still extract and load data from these systems, still put it into some centralized form, but in this case, we put it in a lake form, as in we put it in its raw format, in its file, unstructured, semi-structured file formats, and then downstream from that lake, we create more pipelines to create parameters in the format that can train machine learning models, or we can create these lakeshore marts or data marts that model the data perfectly for the use cases that we have. So it was certainly an improvement to the warehousing model for ML use cases. And the third generation that you see right now is this multimodal way of accessing data. As in you have cloud and, you have lake and warehouse either combined as one technology or separated different technologies. This is just a snapshot of an example of technologies that Google, for example, provides for data on cloud and different tools that people can use to get either insights through reports or machine learning model. And then we've had also a Cambrian explosion around data technologies. This is again from Matt Turk. It's called MAD Data Landscape that he puts together as a VC once a year. And we see this explosion of technologies that are happening. But despite the changes, the evolution that we see, despite the exploding number of tools and technologies, one assumption around how we get value from data has remained. And that assumption is really rooted to that in that 1960s idea of data warehousing. And it's that we've got to centralize data. We've got to get data from all these ubiquitous sources. And then we've got to put it in one place, monolith or less monolith, however, so that we can fuel the innovation agenda of organizations. As you can imagine, this problem is really exacerbated. The problem of centralization and this monolithic solutions is exacerbated in fields like healthcare, because there is such diversity around those yellow and orange boxes on the left. Data about a person can come from so many sources. I mean, this notion of getting data and putting it in one place so that we can generate value is almost comically impossible. And I put this like funny box in the middle just to really point out, no matter how much we become better at storing large amounts of data, computing in a parallel fashion, large amounts of data, from the human and organizational perspective, this is a bottleneck. And that's what data mesh tries to address. If you think about the state of the kind of the businesses and organizations, they're on the bottom, on the x-axis, that the complexity and uncertainty around the business is growing. The number of sources of the data where the data can actually deliver value is expanding. And the use cases, we have moved on from one or two niche, application of ML or quarterly business reports to really embedding ML and intelligent decision-making in every function of every business. So if that's the current universe we're living in, and we want to get, an uplift in the business impact of actually getting value from data, having an architecture and organization model that can be immune to change, to this constant change of sources changing, use cases changing, data changing, then what shall we do? And data mesh tries to kind of address these constraints. In short, it's a decentralized socio-technical approach in managing analytical data at scale. So there are a couple of words I want to unpack in this definition. Naming things is really hard. Defining things is even harder. So so this is the shortest definition I could come up with. But let's unpack it. So it's a socio-technical approach, as in it concerns itself with both the architectural and technical design of the systems that manage and access analytical data, as well as the organizational structure. There is a direct relationship, and Conway, it's known as Conway's law, that your communication structure of your organization mirrors the architectures that you create. So it's naturally a decentralized model. It tries to create a model that can scale out as this complexity, is kind of growing within the organization. And it mainly focuses on analytical data. So what is analytical data? Well, analytical data is data that often scientists and data analysts use. And there's a spectrum of use cases from simple reporting and trend analysis to predictive analysis, as in predicting and training models to making future predictions, or diagnosing and discovering a pattern in the data that perhaps human eyes and logic couldn't discover. But what's really important is that the shape of that data has a unique shape, as in it looks at the data over a period of time. It's a temporal data. You're usually looking at all of the past events and the states of the data so that you can make predictions for future. It has to be business truthful, as in it reflects the reality of the business as much as possible without modeling and massaging, and it's ubiquitous. The data can come from anywhere, and naturally it has a large scale. And when I say data mesh addresses this concern of scale, let's unpack what does the scale mean. Over the course of the last couple of decades, we have addressed many scales, data scales, that are optimizing for the machine. So we, in the 2005s, we found us, I guess that digitalization led to generation of a lot of data, processing a lot of data, and we had to deal with large volume data. So that's when the kind of the Hadoop, category of the systems came to exist. Then we had to deal with variety of the scale of variety of the data. We had structured, unstructured data, voice, image, videos, all of the different types of the data to process. And that's where technologies like S3 and object storage and unstructured data kind of formats that start growing to address this concern. And then mostly with mobile, I suppose, and devices, we had to deal with the velocity of the data, as in the large amount of data being streamed really fast, and we had to respond to this streaming. And that's where the stream processing and Kafka's, Apache Beam, and pulsars and different kinds of technology came to exist. The skill that data mesh tries to address is, somebody wants attention, is the organizational complexity, the human scale problem, not the machine scale problem or machine optimization. It's the organizational complexity that, to get value from data from really complex organizations today, and healthcare is definitely not immune to that complexity. How do we need to rethink, managing data and addressing the ownership of the data? So if the objective is respond gracefully to this complexity, volatility, uncertainty of the change, if we want to sustain agility, as in get value from data with the same, at least, sustained speed as in the face of growth, and get value from our spending, data mesh tries to address the blockers that you see on the left-hand side and create some enablers. So remove that any monolithic bottleneck, any centralized bottleneck, whether it's governance, whether it's platform, whether it's like data itself, address any fragility. Any system that requires coordination, it's a very fragile system. And you folks that are really embedded in the computing side of it know that, we do parallelization, and in parallel computing, we try to remove any point of contention and synchronization. So any human system and logical, computing system that requires synchronization creates fragility. This idea of moving data from one place to another place by usually different teams, different silos, creates a lack of data ownership. I mean, who owns that data? Who's responsible for the data? Is this some centralized group? We call them the magical data group. And that, siloing of people leads to this lack of talent, because we are forever and ever chase these like hyper specialized data people. How can we mobilize a larger population to be able to use data, manage data, own data, and create a governance model that can actually scale rather than become a control bottleneck? So this is a promise of data mesh. One way of introducing a complex concept is starting with its first principles. These are 4 principles that underpin that decentralized data management for analytical use cases. The first principle is around this idea of domain ownership, as in, think about a large complex system as domains. Domains are a sphere of, business that have a ubiquitous language. For example, example of retail. Apologies, you folks are in medicine, and I keep using retail because it's simple and kind of people from different disciplines understand this. You have the people that deal with order, people that deal with customer, people that deal with e-commerce, people that deal with call center. These are kind of the domains of the business, and they can fairly independently operate with, kind of a set of contracts and interfaces. So we're extending that concept to data and saying, okay, these domains are actually accountable for owning the data that they use and the data that they share. And then the second principle is about thinking about data, not just an asset that we control, but data as a product that we share and we delight the experience of users of that data. So if the domain of, the customer management domain is dealing with kind of capturing the state of the customers over the period of time, their profile, their portfolio, their risk category, and that sort of kind of understanding the customer, then they're providing that information as a product, that analytical data to the rest of the organization, so that marketing can do the right outreach, or sales or support can do their job. And the third element is, how is it possible, like, to make this domain ownership of data and domain ownership sharing of the data? We need a kind of infrastructure that really empowers these different domains and give them autonomy to do their job really well, and do that in a self-serve manner, so they don't become, again, a centralized bottleneck, so that all of the technology stacks needed to share and connect and use data products becomes the data part of the self-serve data infrastructure. And finally, to put some sanity around this distributed domain-oriented system in a way that the data quality is not sacrificed, in a way that the interoperability across these data products exists. So, for example, if you're generating kind of a higher order intelligence, connecting the customer information across different domains, there is a system of interoperability that allows you to do that, to identify, oh, this is the same customer across different domains, or this is the same patient across, you know, these clinical visits that they do, and across these pharmacy claims that they made, and its lab results is the same patient. So there needs to be some level of governance that data mesh, again, think about this as a dynamic system, and creates a federated operating model around this governance, and thinks about computation as a first class concern in automating a lot of the governance concerns, but for the same outcome, for this outcome of integrity, interoperability, accessibility, security, and privacy. So why we have 4 of these first principles and not 2 or 3? This is my rationale. I think the main principle is this distribution of data ownership. But once you distribute a system, you can cause anarchy, right? You can create data siloing, as in, if I'm in let's say the pharmacy domain, and I'm dealing with pharmacy information, I have no incentive of sharing that data with somebody who's concerned with you know, using that perhaps pharmacy information for, you know, improving the next generation medication and connecting the dots in terms of like the patients and the medicine that they use, so that the data as a product tries to remove that siloing, create an incentive, and also guidelines around how to treat that as a product, so that we can share with the users. The self-serve platform is really to empower these teams and reduce the cost of ownership of these data products. The governance, again, is around increasing engagement, reducing that domain isolation by creating interoperability, and also interconnecting these data products to create, you know, higher value data products, right? Again, the platform is in the service of governance in terms of automating all of the policies that we want to put around the data. So software engineering and automation is a big part of that computational governance. If I want to, again, give you I guess, a picture of what does it visually look like, going back to retail domain. So you've got retail business, and they don't have this dual plane. If you remember, we had this operational data plane and analytical data plane on the right and left-hand side of one of our previous slides. And these now overlap. And the point of overlap is teams or business domains, cross-functional teams that concern themselves with business outcome, applications that serve that business, and now intelligence and data that really both emit what that business is generating as data as a product, as well as using that data as a product to augment those business functions with ML, right? So that logistics application is, instead of using a rule-based, for example, you know, logistical decision where to move the products from which warehouse to what retail store, is now applying, let's say, an optimization data, a machine learning model, using the data as a product that it has generated over the past, and using the data that, let's say, other domains have generated to train those machine learning models and make the best optimized routing decisions for, let's say, logistics. We have this kind of the idea of a self-serve platform that, yes, there is a team, and there might be a centralized team, but their job is providing the technology that gives an experience, an intuitive and, you know, kind of natural experience to these cross-functional teams to manage and serve and use data. And finally, we have, you know, a federated model of different teams, again, being responsible, have the accountability for providing interoperable, standard, you know, high integrity data to the rest of the organization, following a set of policies that have been computationally expressed and embedded into these data products. And I know a lot of these concepts are fairly complex and deep. And I hope that you will, if you're interested in this, you'll get your hand on the book and it will go fairly deep in each of those pillars. Just put this in perspective, I wanted to give you again that example of a healthcare payer provider. One of the, in the kind of the healthcare ecosystem, one of the holy grails that every healthcare platform is looking for is this idea of longitudinal health record. That for every single member in the universe of the ecosystem of these perhaps partners, providers, hospitals, clinics, labs, pharmacy, and so on, there is the idea is that they want to create these data-driven kind of personalized applications based on that understanding of the member or the patient's history, the longitudinal health record. To get there, we have two approaches, right? We have the centralized approach of, well, let's keep collecting data from every partner that we can, and every organization collects their own data and centrally collect that data so that then they can make this informed decision. The data mesh approach, which was a platform that we built for this particular organization over the course of 3 years and is still going on, is that instead of saying, let's collect all of this data, saying, let's externalize the data from the different domains like member profiles, the pharmacy claims, medical claims, lab results, all of these domains as independent data products, and let's connect them. And let's generate value through interconnection of these domains. And then to support that, of course, we've got to kind of use a technology that, to be honest, today, really none of the technology we have is designed to serve this decentralized model, but that's what we have to do with. Most of the technology we have today is optimized, that cloud platform or infrastructure that we see is optimized really for that pipeline centralized model. But I think very quickly we're moving to unbundling that into and rebundling it back into this mesh or network topology model. But then, underneath that, you see a set of technologies. The icons used here are from Azure platform. And then underneath that cloud platform, you have your pure play of compute, networking, storage, and so on. So this particular client made a heavy investment in building a data platform, that self-serve platform that gives autonomy to these different domain teams to build and share data products so that they can rapidly apply analytics, data science to the data that being now shared. And we worked on a multitude of use cases. This is just some examples of this. But what we experienced with these use cases was that it was we could so easily and quickly and rapidly respond to these use cases because we were using this decentralized or distributed model. So I give you the COVAX, or there were COVID use cases. There were a series of use cases around understanding what was happening around COVID. Very early days, what was happening in the population in terms of the symptoms, in terms of what patients were coming with and accessing the provider, where the outbursts were happening, to later on, picture of the vaccination status and so on. And instead of saying, traditionally, if you wanted to respond to this COVID use case, we would say, oh, data team, the centralized data team, now you have a new use case, you have all these other use cases. You have now another use case to prioritize across, your very long backlog, and build a solution, capture this COVID data from all of the systems we have, and then, generate some insights around it. Alternatively, with data mesh, what we said was, well, this is a decentralized system. We're going to put a team together. Their job is generating data and insights around COVID information. They can operate autonomously and independently, and they're responsible end to end. As in, there was a chatbot on the platform capturing the conversations with members, doing NLP, and generating a set of data products that were applying the natural language processing and coming up with some sentiments and insights around that, and sharing that data as an insight that then it can be fed into other data products downstream that they were trying to change the behavior of the organization, in fact, in responding to this. And they put this whole thing together in a span of a week or so. Of course, there were many sleepless nights, But that self-serve data platform were giving them the tools they needed to autonomously put this together. The cross-functionality of the team were giving them all of the information and the business understanding to really create this data product with understanding of the business context directly, not in an isolated fashion. And really did outcome all the way, like it was all praise from the CEO of this really large organization. And there are some other examples I put on the slide here to have a look. There was a claim of reducing kind of the potentials around breast cancer, for example, by having timely and targeted outreach for people that are high risk to do their regular screening. Of course, underneath all of that, there's a business, there's insurance business running, and they don't want people get sick, so they don't want a high cost. But it was good for the business. It was good for all of these use cases, good for the population. What was built, again, if you think about the data mesh, put this in the language of data mesh. The use cases, we had about 50 plus. And again, this data is a bit outdated. It's from 2021 and things have changed and evolved since then. But in the course of a couple of years, what the folks achieved were, 50 plus data scientists and analysts working with 300 different data products that were being generated by about 50 data product developers. And the use cases were patient 360, the longitudinal health record, population health, COVID cases, clinical care decision, like how do we put a care team together that is perfectly targeted for different classes of patients, right? So if I'm a healthy individual, I probably don't need a healthcare team. I deal directly with different, specialists. But if I'm elderly and I have kind of Alzheimer and I have all these underlying issues, probably I need a group of specialists working together around my care decisions. So they were organizing the care teams differently based on the classifications of the patients. Jumping on up to the kind of the policies that we automated, there were a lot of policies around privacy, as you can imagine, what information can be stored in what way, who can access what. If it's, say, patient, and we use a single ID, how does this patient, we call this idea of polyseams, how does this patient get identified uniquely across all of the different data products? And we can interconnect those. And we automated all of these as part of the code that you can, as a data product developer, you declare. You will say, privacy level of my member profile is this level, and these fields are, confidential and PII, and the patient ID is this field, and the rest of it is computationally taken care of by the platform. When to encrypt and how to enforce access control. All of that was done by that yellow layer. There were a ton of advances in the kind of the platform layer to really reduce the cost of pulling all of these technology pieces together. And on the left-hand side, you see some of the outcomes that were generated. So I talked about these 4 domains. I talked about this logical architecture. We have 15 minutes or 40 minutes, less than that. Maybe I quickly touch on a couple of these pillars. I won't be able to go through all of them, but the main one, right? The main one, this domain-oriented ownership. Oh, I got a heart from my daughter. That's very nice. Thank you, Mommy. This domain, what is this whole domain ownership? Why are we applying it? In about 2003, for people who were in the software engineering world, I suppose might be familiar with this concept of domain-driven design. Eric Evans noticed, a lot of people noticed, but he wrote about it, noticed that it was really hard to build these complex monolithic systems. Any organization that had multiple people talking to each other, building different systems, were being challenged to tackle the complexity of this system, so that if you make a change to the system, the whole thing doesn't fall apart. So he came up with this idea, again, breaking up teams and systems around the domains of business. So I didn't come up with the idea, I just applied it to data. And he basically said, we can't try to or centrally model the universe of our applications. We can't not have any modeling. We can't have models that are independently created. So he came up with a kind of an approach for modeling systems. And it's a very well thought through approach if you are dealing with a complex system, how to break it apart. And he introduced the concept of bounded context. So that, let's say you're in the members domain, you can kind of find these bounded context areas of the business that are really about one concept, and you can put a line around it and say, okay, this is a language that says how we express and model that aspect, like member profiles, let's say. And this is how this model relates to all of these other models. And let's create a ubiquitous language for that particular bounded context, not for the universe, right? And do a mapping between one bounded context to another. So this idea then, if you apply it to big data, that's what we end up with, that we have different teams working on different data, pieces of data as a product that are aligned to the business. And there is a mapping and connection between these data products. And this is an example of retail that I've talked about, I guess, through the course. And to prevent, again, the silos, if I go back to prevent that in the retail, the distribution and production, or distribution and selling can actually talk to each other. When somebody says, I'm selling this, I'm producing this shirt, and the purple guy is in the selling domain saying, I'm selling this shirt, we know that this is the same shirt. We can follow through this policing relationship. So there is the context mapping in action, I suppose. But we have to prevent siloing, right? We have to prevent sales and marketing and different domains not speaking the same language, and that's where the product thinking comes to play. The data, the principle of data as products. Sometimes it's hard for me to describe what a product is, but the description that I love to use and build upon is the description defined by Marty Kagan in his book Inspired, that every good successful product is at the same intersection of being usable, valuable, feasible. So assume that member profile or information about the patient is valuable and is feasible to generate. But what does it mean to be usable? What are those baseline usability characteristics of a data as a product? So a data as a product is something that should be discoverable independently. And many of you may have heard from the FAIR principles. This builds on the FAIR principles to say it needs to be discoverable, understandable, addressable, secure, and so on and so on, to really be categorized as a product. So you have, if I'm sharing orders information, the data scientists and data analysts should need to be able to access that data in their mode of access, whatever is native to them. Maybe they're running SQL queries, maybe they're reading files or Parquet files. They need to be able to trust this data. So this data not only conveys the data, but also all of the metadata, real-time, up-to-date metadata, so that they can say, oh, this data has this level of completeness, it's being updated every hour or every month, whichever it is, so that I can trust it to be usable for my application. And of course, this data needs to have additional information, such as documentation, maybe computational documentation, to show the characteristics of the data, to show how this data can be used, what's underlying it. It's not just a CSV file with human encrypted names of columns that nobody really understands. There is a concept introduced by evolutionary architecture, which is at the intersection of, again, evolutionary science or evolutionary computing and architecture, that says if we want to generate these data as a product, as an autonomous, independent piece of software and data, we have to think about all of these elements so that it can be independently deployed and managed and have high functional cohesion. So when we talk about data as a product, really as a quantum, we talk about, of course, the data itself in multi-modes of access, the file mode of access or streaming mode of access or whatever mode of access. But we also talk about the code that is maintaining and transforming this data. Data is never, ever static. I mean, data that is static never changes. It's an archived data. But the data that is generating value based on today's reality, it's always having a code running it and transforming it and generating it. So it encapsulates the code that generates. Now, of course, it has to run on this data as a product, it needs to run on some infrastructure. So it needs to articulate what are its manifests and what are the infrastructural components that it has dependency on. This gets a little bit, I guess, detailed in terms of, okay, what is the architecture of this data as a product? I'm going to leave this slide with you to have a look, but essentially, we're talking about a new concept that is continuously receiving information from upstream sources, is continuously transforming, is storing and also serving data with some constraints around it. We said analytical data, so it's bitemporal, it's multimodal access, and it allows some APIs for controlling it, to set policies, to set privacy, to set retention policy, all sorts of policies, and also it emits information so that it can be understood. It has documentation, it has metrics around it. So it's a new concept. There isn't a single, let's say, technology out there that's really bringing this concept to life as one unit. And I think that's, we will see hopefully in future advances around that. In terms of platform, I think a lot of you folks deal with IT and platforms. The job of the platform is really allowing producers and consumers to exchange value and lower the cognitive load of them doing that, right? Lower the friction in doing that. And often, we talk about the culture of innovation. That's innovative. I meant innovation, innovative, not innovative. That's a funny word. I just noticed it. The culture of innovation is served by ability to share data more easily, right? So that you can hypothesize about a possible application of data and you can easily access it, find it, understand it, put it into your test or hypothesis. And data platform, the way I see it, is a set of capabilities that allow you to do that without worrying about, oh, I need to provision all of this infrastructure and get somebody else to do it for me, right? You don't want to be in that mode. You want to be in a mode that you can self-serve. Instead of asking people to do things for you, you can just do it for yourself. The cognitive load is lower, so you can do it. And data mesh has a way of kind of defining or structuring the capabilities of this platform so that as a data product developer or user, you can really go through your journey without friction. You can go through incepting the idea of data sharing, what data I'm sharing, and really bootstrapping, maintaining it over time. And finally, the governance is really the last pillar that brings all of it together is the governance. And the job of the governance, as we said, is really getting the right data to the right people at the right time with the right level of integrity. But in case of data mesh, I think the governance need to embrace this equilibrium between localization and optimizing for autonomous domains, as well as this global harmony and global security across all of them. And really embrace this idea that this is a dynamic system. We can't really put it in a straight jacket, try to say, oh, this is how we're going to control the system. Control is not going to work for a dynamic system. And of course, we're heavily relying on competition and software. So let's leverage that platform. A lot of my thinking around how the governance should work, it comes from Donella Meadows or Peter Sinch, people that have thought about system thinking, and instead of thinking about little pieces of the system, think about the system as a whole and interplay of these elements. And it's really inspired by this work that today's governance is about control. You have people sitting in the middle and saying, okay, this data can be used or can't be used, and they're the central people for controlling access or certifying. Great intentions, but poorly executed and impossible to be executed in a decentralized way. So in system thinking, there are other concepts that get introduced, such as leverage points, such as feedback loops, to maintain, again, that equilibrium. The system's continuously changing, but there is an equilibrium, dynamic and equilibrium that is maintained. And in case of data mesh, again, this is a complicated subject. I leave the slide for you, but we're really embracing teams who are closer to the data, be accountable and responsible for data because for their domain, because they are best positioned to do that. They understand the data, they are accountable for sharing it. Hence, they should be accountable for the policies, right? Those global policies, the standards that need to abide. But the platform, again, allows you to embed those policies computationally in every data product. Like the example I mentioned, like declaratively just mentioned, this data product is privacy level X, and that definition, that declarative definition gets translated to functions within the system that at the right moment, at the right time, impose what the access control or encryption implementation should be. This is another example around, let's say, quality. We decide what the quality, how do we want to articulate quality for data? There is a standard we can pick, I mentioned here. And then the platform makes sure that there is a agent or function running within every data product that emits those quality metrics, and people responsible for the data products can articulate and guarantee their quality metrics of the data product, such as its timeliness, such as its completeness, such as its integrity. And to get started, we have to think about the whole. We have to think about big picture before diving into the kind of the details. And the big picture is this: that you have this holistic cycle of intelligence. That data, where people and systems interact, they generate data as a product around the domains, and that leads those data products get connected again into visualization, into dashboards, into machine learning models trained to augment the actions with intelligence, and the platform is really there to support them. This is going to be a journey of 1,000 miles to get to such a transformation and implementation. And I'm glad that you were here with me to take the first step and listening to this talk. I'm open for questions, but I know I have probably exhausted my time already.
Oh, great. Thank you, Zhamak. That was great. So I'm going to actually ask you the first question. So definitely, the whole idea of domain-driven design is very suitable for highly innovative environments like universities, like healthcare. You mentioned about COVID. We lost over 6 million people during the pandemic. So we have to move fast, of course, and reduce synchronization and coordination. But then we get to the friction point, which is, you mentioned about this whole governance. How would you convince the other side, those guys who are in favor of, centralized systems, kind of like, hey, this is the way to do it, because, you get a lot of pushback.
Data-driven, data. I mean, one way to really surface the challenges is capturing and sharing data. And one of the pieces of data, or some of the pieces of data, are around time to value, lead time to value. So, or around the friction to get to value. For example, if one department or one units within, let's say, universities doing research, and they have a hypothesis around how a particular set of data can be used, but measuring how long it takes to go from that hypothesis to actually get access to the data, validate hypothesis, to see whether it's worth pursuing that hypothesis or actually leaving it, measuring how long it takes and surfacing those friction points could be a starting point, right? Because those that cost can be translated to loss of opportunity. I mean, the cost of missed opportunity is something that we usually don't measure.
Right.
We measure how much money we spend on people and systems, but we don't measure what we lose by not being able to act. So that's one way, but that's only one way. Education is another.
Great, definitely, and also, what about the enforcing these policies, because they were like, everything is good until, one team is actually doing something wrong and would impact the integrity of the whole organization. Yeah. So how can we make sure that, they follow these, regulations and policies?
I mean, the whole idea of embedded computational policies in every data product is a powerful one, and I know I superficially touched upon it, but I give you an analogy in, let's say, cloud computing. So the idea is that every piece of software or every process that transforms and shares data embeds in itself, as in a standard way, how to validate and enforce the policies. And that standard way is a blueprint that is provided by the platform. So even though people have autonomy to really focus on the logic and the modeling of the data in their domain, but they are adopting a standard blueprint that essentially controlled and provided by the platform that puts the guardrails that needs to put in place, but not human guardrails, machine guardrails, right, automatically. As an example, in the cloud computing world, we have this concept of zero trust architecture, as in the past, if we wanted to trust someone to use the system or not, we put a perimeter around our systems and say, anyone in can use the system, anyone outside of the firewall can't use the system. And then we quickly realized with these decentralizations of web applications or cloud applications, that just didn't work. So then we say, there's zero trust. We trust no one, whether you're in the system or outside of the system. We put all of the computational monitoring, observability, access control, we bake that into every single piece of software, and we enforce it on every endpoint access to data or writing data, and we constantly monitor and recover. So this application of really automated processes, so that you assume actually the system is as a whole completely unsafe, zero trust, you trust no one. And these are proven concepts, we just have to bring it to the data.
Yeah, so we're still going to have a global governance unit, but it's more like a, as you pointed out, it's a cross-functional team, right? It's coming from the experts, not from, you know, outside of the team. Domain experts are going to make those policies, right?
Yeah, absolutely. You can't get away without, you know, having those global policies defined in a standard way that applies to everyone, right? We can't say, oh, everyone go and implement security however you want. The job of that global team is really define what constitutes security. The job of the platform is really automating that into the blueprints of our processes and applications. And then it's the job of every domain to really make sure that security is enforced and complied with in their domain. And those domains actually come together to create that federation of the governance who decides what these policies are, because they have a stake in it, right? They have a local responsibility of making sure their own data is secure, but also a global responsibility that that security is a consistent cross-functional concern across the domains. So it's not really a third party doing that, it's the domains coming together with SMEs and subject matter experts to decide on those policies. I think this model is still, you know, is still an experimental. I claim that we have really solved it, but I think it at least tries to address some of the blatantly obvious, like, you know, friction points that we have.
It's the future. So any questions from the audience here?
The chat was awfully quiet, so hopefully I didn't put you to sleep, but if you have any questions or any comments, I appreciate to hear your thoughts.
Help me. Look. Look.
All right, I think your daughter was like the youngest student today.
She was. You had a kindergartner in your class today.
Okay, I think we have a question here for you. There's a question to ask you. Can you talk more about the pharmacy case?
Yeah, so this wasn't particularly a pharmacy. Oh, yeah, so we had, there is a pharmacy case around the RX. There were multiple pharmacy use cases, but again, this is a perspective of a payer, an insurance company that has affiliation also with like pharmacies and providers, and they can exchange data as a product with each other. This particular use case was around RX authorization. So as you know, there is a process that at the point that a provider, a doctor wants to make a prescription, recommend a drug, they have to validate with insurance prior to that to see whether the insurance covers the medication or not. It's called RX authorization. And existing technology is very much rule-based. So if, you know, then that yes or no, a lot of those rules that, you know, grow over time into a really, you know, hairy kind of rule-based system. And those systems have a large degree of false negatives, or depending how you see it, as in they falsely assume that you're not supposed to get the medication, and you can imagine that kind of the human consequences for people that actually require that drug to be able to even live a day. So what they were trying to do is move to an ML-based system. It's not a rule-based system that exploits data, again, longitudinal human record, as in all of the information about the various medication that the patients are using, around the previous medications, around their health conditions and diagnosed conditions, and given that, create a classification model that would give you a yes and no kind of answer on this. But to even, you know, enable such a crucial but maybe relatively simple case, you can imagine the bottleneck is really access to data from diverse sources of it. So data mesh was, again, a good candidate because it will allow you to, over time, enable more of these domains and evolve your machine learning model to exploit new features, I suppose, for that ML model. So that was one of the pharmacy examples that we had.
We have a question here for you.
Hi, thank you so much for coming to talk to us. I was wondering what your thoughts were on like the next few years as it pertains to this like domain data and whether people that like produce it, especially in the medical field, could own it or like be reimbursed for it. Like a really rare patient with a disease, like their data is like really valuable. Or yeah, well, what are your thoughts on like people being reimbursed for the data?
Yes, I don't have, so there's a personal view on that, but in terms of if your question is around me as a person owning my data, the self-sovereignty of the data or data sovereignty, I don't see really people deeply thinking about it. So what I can see right now happening in the industry, because of my, I guess, vantage point as the creator of the concept, I can see that the domain-oriented ownership, as in business domains owning different parts of the data, or as custodians of the data, managing long-term ownership of data, is really resonating. So CDC, CMS, all of these like healthcare organizations, or even private healthcare technology providers. There are numerous, like this concept has resonated widely, and I can see that in the industry. Everybody has a data mesh strategy. So that hasn't, but the next mutation, I think next evolution of this decentralization goes from business domains owning controlling data to individuals, the sovereignty. So domain sovereignty to individual sovereignty, that you and me as a person, we get reimbursed and we decide whether we share our data or not with whom based on the value that those people provide to us, right? I think, unfortunately, I mean, I love to see that future personally. There are pieces of technology that had to be put in place, such as decentralized identities and so on, that are yet still evolving. And there has to be a business model that supports it, right? At the end of the day, it's all about bottom line. And I have some hypotheses that what would be the catalyst for the self-sovereign data world, but that's far beyond the data mesh conversation. But I appreciate the question.
Thank you.
One more question for you, Zhamak. So speaking of this domain-specific teams, let's assume that one team is working on EHR. I think you mentioned that, and then the other team is working on genomics. But then how are these guys going to communicate? Like, like at some point, like saying that, okay, this genome is actually from this particular participant, right? Yeah. Is there going to be, again, a universal system to assign these UUIDs and?
Yeah, that's a really good question. So the coordination of IDs has to happen somehow, right? And there are multiple ways of going about it. If these two teams completely independently evolved, the moment that they decide that we're going to have a contract with each other, as in we share data, as part of that contract, they need to do that context mapping. If you remember from that DDD concept, the concept of context mapping, as in saying, my ID of this member, or this patient, this person, is mapping to your ID of this genome owner that you have. So that context mapping can be done. One way is like, we're all going to agree on a universal ID, and that's a very hard system to develop. The other could be, we're going to create some really smart services that can tell us, again, ML-based services, yes and no, given these parameters, is this person the same person as the one in this domain? And if it is, let's create a hyperlink. Let's create a linkage between these two systems in terms of the ID mapping. These two IDs correlate with each other and create a context map. So I think it's an area of definitely, I would say, research and development, but a simplistic implementation of a universal IDs. I mean, some countries, of course, have implemented digital IDs and universal, like India and so on. maybe that works, but we need to have an incremental way of getting there. And that, to me, the incremental way is creating perhaps contracts between context mapping between domains, so that you can traverse these context maps, right? If you're collecting data, let's say from now genomes and these member profiles and another domain, you can follow kind of the mapping or the linkage between two. But I'm sure there are, smart distributed system thinkers that can come up with better systems that I just defined. But the key, I think, would be really mapping and linking, as opposed to a single ID rule them all, at least in the interim.
Makes sense. Thank you, Zhamak. Any other questions, folks online or? Well, let's thank our speaker. Thank you so much. We appreciate it.
Thank you.